Hello, this is Mrs. Taylor, and I'm going to walk you through how to apply the second derivative test. So to start with, you need to know what the second derivative test is. And the second derivative test states, let f be a function such that f prime of c equals 0, and the second derivative of f exists on an open interval containing c. If f double prime of c is greater than 0, then f of c is a relative minimum. And if f double prime of c is less than 0, then f of c is a relative maximum. If f double prime of c equals 0, the test fails. In such cases, you can use the first derivative test. So what this is saying in non-notation speak is if your first derivative equals 0, so if you have a horizontal tangent line, and your second derivative is positive, greater than 0, then there's a minimum at that c value. And if you think about it, if the second derivative is positive, that means your curve is concave up. And so it would make sense at this point where the tangent line is 0 is a minimum because it's concave up. And then if the second derivative is less than 0, that means it's concave down. So if I have a horizontal tangent line at C, then it makes sense that that would be a maximum. So if you visualize what this is saying in words, it helps. So let's apply the second derivative test. Find the relative extrema for f of x equals negative 3x to the fifth plus 5x cubed. So to use the second derivative test, first I find the first derivative and where the first derivative equals 0. So my first derivative is f prime of x equals negative 15x to the fourth plus 15x squared. And immediately I see that this first derivative would equal 0 at x equals 0. Let's see if it equals 0 at other places. So I'm going to start by factoring. Once I have my derivative factored, I can see that the left factor here will equal 0 when x equals 0, and then my right factor here will equal 0 when x is positive or negative 1. And so my derivative equals 0 at x equals 0 and positive and negative 1. The next step would be to take the second derivative. And the second derivative is f double prime of x equals negative 60x cubed plus 30x. And if I want to find the extrema using the second derivative, I take where my derivative equaled 0. So x equals 0, x equals 1, and x equals negative 1, and I evaluate the second derivative at those x values. And all I really care about is if it's positive or negative. So I don't have to know the number, I just need to know if it comes out to be positive or negative. Once you evaluate your second derivative, you see that at x equals 1, the second derivative is negative, which makes your function concave down. So at x equals 1, there would be a maximum. And then when x equals negative 1, your second derivative is positive, which makes it concave up, your function concave up. So that means that that would be a minimum. Now here at f double prime of 0, my second derivative equals 0. So if I wanted to test for extrema x equals 0, I have to go back to the first derivative test. I still want to state what I found so far, and I have a maximum at x equals 1, a minimum at x equals negative 1. Remember it says extrema, so I need to find the y values. I find those by plugging in these values back into the original function. So f of 1 would be negative 3 plus 5, which would be 2. And so I could rewrite this as a point 1, 2. And then my minimum at negative 1, well, that would make this a 3 minus 5, which would be negative 2. And then the last thing I have to do is I need to test this x equals 0 as a first derivative test. So I'd create a sign chart and find if it was an extreme value that way. And so I would take my critical values, I would place them in a sign chart for the derivative, and I'm really only concerned with 0. I already know about -1 and 1. So f prime of -1/2, looking at the first derivative, this would be a negative product here, and then in parentheses with -1/2, I would get positive 1/4 minus 1, which would be negative, so it would come out to be positive. And then positive 1/2, again, I'd have a negative factor here, and then inside of my parentheses, that would give me 1/4 minus 1, again, would be negative. So no matter what, to the left and to the right of 0, I have increasing function. And so there is no change, therefore x equals 0 would not be an extreme value. So now that I've tested all the possible points for extrema, I've concluded using the second derivative I have a maximum 1, 2, and a minimum -1, -2.